All right, chem students, today we're going to talk about precipitation reactions. You'll need your blue notes packet and something to write with. Precipitation reactions are a type of double replacement reaction. Two solutions of ionic compounds are mixed together, and one of these products of the reaction is going to be an insoluble salt called a precipitate. So you have two liquids that are put together, and a solid is going to appear. We have solubility rules that help us to determine the identity of a precipitate. It will also tell us if a precipitate will be possible. So we'll write the products for these double replacement reactions and then balance them. Then, using the rules, we'll identify the precipitate by a subscript, in parentheses, S, for solid, or if it's still aqueous, we just put parentheses with AQ in it. So for our first example, we have silver nitrate and lithium chloride. First thing we need to do is predict our products. First product is going to be silver chloride, and our second product will be lithium nitrate. And we can check to look, this is balanced, so I don't have to balance it. So now I have to decide which one of these is solid and which one of these is aqueous. So for the first one, I'm going to look at silver chloride. Now, let's scroll down here to include our chart. This is on the back of your periodic table, and it tells you what to expect. So soluble compounds will contain the chloride ion. So that's what we always look at. We look at the second one. So for silver chloride, we're looking at chloride ion. Chloride ion is right here. Chloride ion is soluble except for compounds with silver in them. So soluble except for compounds of silver. We are bonded to silver, this one. So this one would be insoluble, or S. So I'm going to put an S up here. That's my precipitate. We'll go ahead and check. We'll check lithium nitrate. For lithium nitrate, we're looking at the second part. So we're going to use the rule for nitrate. NO3 is right here. Nitrate is always soluble, no exceptions. So you can be confident that this one is aqueous. So I'm going to label it up here, aqueous. So for this one, silver chloride is going to be the one that has the precipitate. It is solid. Okay, let's do a couple more examples. For sodium carbonate reacting with calcium nitrate, first we're going to predict our products. First product is going to be sodium nitrate, and it's going to be calcium carbonate as the other product. We'll need a 2 here to balance this, so that's already done. Now we have to decide what rules are we going to use to determine which one is our solid, which one is the precipitate. NO3 is going to be my first one. For sodium nitrate, I'm going to look at the nitrate. So nitrate, down here, soluble compounds with nitrate. Nitrate, always soluble, no exceptions. So I can automatically say nitrate, going to be aqueous. For calcium carbonate. Now, you can't just assume that this is going to be solid, because we can give you a problem that has two liquids as products. Maybe there isn't a precipitate. So we'll check. Calcium carbonate, I'm looking at CO3. So that's the rule I'm going to use. CO3(2), I'm going to scroll down, is down in the insoluble area. So CO3, so it's going to be insoluble unless it's bonded to NH4 or an alkali metal. Oh, calcium is not an alkali metal, it's an alkali earth. So this one is going to be insoluble. So we can go ahead and label that solid. Now for the next one, potassium phosphate reacting with magnesium chloride. First product is going to be potassium chloride, and the second product is going to be magnesium phosphate. So these are balanced and ready to go. We want to look at chloride ion first. For KCl, we're looking at chloride. Chloride is down here. It is going to be soluble unless it's bonded to silver, lead, or mercury. That is not silver, lead, or mercury. So we know it's soluble. We can label this aqueous. For magnesium phosphate, we're looking at phosphate here. That's the important one. So we're going to scroll down here. Phosphate is insoluble unless it's bonded to NH4 or an alkali metal. Magnesium is not NH4, and it's also not an alkali metal. It's an alkali earth. So we know that this one is going to be insoluble. So we can label this one a solid. All right, that's it for the solutions videos. Make sure you do the corresponding practice pages, and good luck on your test.